This is a recast of the 6,100-word piece named Entity Linking, NEL, from Schnappat AI. This article is about named entity linking and its applications in natural language processing. Let's listen in.
The article is about named entity linking, or NEL, and how it's used in natural language processing and artificial intelligence. NEL is a process of extracting meaningful entities from a text, like people or places, and linking them to external knowledge sources.
That's right. It's a crucial task for machines to understand context and make progress in AI. It's used in things like information extraction, question answering systems, and machine translation. Now, let's look at the specifics of named entity linking.
Sure. First, let's define it. Named entity linking is a task in natural language processing that involves recognizing named entities and linking them to an external knowledge base, like Wikipedia or Wikidata.
Right. And this process involves three main steps: recognition, disambiguation, and linking. In the recognition phase, entities such as people or places are identified using techniques like rule-based matching and machine learning methods.
That's right. Then in the disambiguation phase, context is analyzed to differentiate between entities with similar names. Finally, in the linking phase, the entity is linked to a corresponding entry in the knowledge base using a unique identifier.
Exactly. So why is this important?
Well, named entity linking is an essential aspect of natural language processing that's becoming increasingly popular due to the amount of digital information out there and the need for automated text analysis. NEL offers several advantages over traditional methods of entity recognition and disambiguation, like using context and external knowledge sources for more accurate results.
It certainly has the potential to revolutionize the field of NLP and unlock new opportunities for businesses and researchers alike. Now let's look at how it has evolved over the years.
Absolutely. NEL technology has been around since the early 2000s and has seen steady development ever since. One of the first systems developed was BLINK in 2006, which focused on disambiguating entity mentions by linking them to Wikipedia pages.
Google then released Freebase in 2009, which was a knowledge graph containing information on entities and their relationships. There have been several other systems developed since then, each improving upon the previous iterations and expanding the capabilities of this technology.
That's right. In summary, named entity linking is an important part of natural language processing that involves recognizing named entities in a text and linking them to an external knowledge source with a unique identifier. This allows us to get more accurate search results and better understanding of unstructured data at scale, which can be beneficial for various applications such as information retrieval and question answering systems.
Correct. Named entities, NE, are terms used in natural language processing to describe objects, concepts, and different types of things that are named or labeled, such as people, organizations, locations, scientific terms, and other entities.
It's essential for recognizing NEs as it helps to identify and classify them into different types such as people, organizations, geographical locations, products, events, and more. This is crucial for many natural language processing tasks and plays a vital role in text analysis, information extraction, and machine learning applications.
That's true. And while both entity linking and entity recognition both involve recognizing named entities, entity linking goes a step further by providing additional information and context about these entities. It allows for more precise identification and disambiguation of entities, as well as connection to other relevant information sources.
So how can this be done? There are two main approaches for named entity linking. The first is through machine learning algorithms such as support vector machines, SVMs, random forests, and neural networks. The second is through a rule-based approach, which involves the use of manually created rules and patterns to extract entities from a text, which can be highly accurate when the rules are well crafted and the system is used in limited domain settings.
That's right, but it does come with some drawbacks such as scalability and maintainability issues, since the systems need to be updated frequently to keep up with changes in language usage and domain-specific terminology.
Got it. So overall, named entity linking continues to evolve with new and innovative techniques being developed to improve accuracy and efficiency.
Yes, and one of the most popular techniques is the machine learning approach. This approach trains a model using a pre-labeled data set that includes entities and their corresponding knowledge base identifiers, which the model uses to recognize entities in an input text and link them to the corresponding knowledge base entries.
That's interesting. So now, can you tell us a little bit about the hybrid approach?
Absolutely. The hybrid approach combines the advantages of both rule-based and machine learning-based methods to identify and disambiguate named entities with high precision. The use of machine learning enables the system to learn and adapt to new entities and contexts, making it more efficient and accurate over time.
That's great. So what are some practical applications of named entity linking?
Well, it has numerous practical applications in various fields like information retrieval, text mining, natural language processing, and knowledge management. It is used in building structured knowledge graphs to represent real-world objects and their relationships. Additionally, NEL can be used in entity recommendation systems, cross-lingual information retrieval, aggregation of news articles, and organizing social media feeds.
Wow, that's a lot. What about named entity disambiguation?
Named entity disambiguation, NED, is a subtask of the NEL framework that aims to identify the correct meaning of an entity within a given context. It involves computing similarity measures between the entity mentioned and candidate entities in the knowledge base. Various methods have been proposed for NED, including graph-based and machine learning-based approaches.
And finally, can you tell us about entity retrieval?
Of course. Entity retrieval involves identifying entities based on a given query. It can be either contextual or non-contextual. Contextual retrieval takes into account the surrounding text or document, while non-contextual retrieval only considers the query itself. The effectiveness of entity retrieval methods depends on their ability to understand the context of the given query, which can be inferred from the query or extracted from the surrounding text.
Interesting.
Because of the ambiguity and variability of named entities in text and the complexity of knowledge-based schemas, this task is difficult. However, with advances in machine learning, algorithms, and natural language processing techniques, significant progress has been made in NEL and its applications in different domains.
And this brings us to knowledge graph generation, which is a process of creating a structured representation of the information extracted from text. Knowledge graph provides a useful resource for tasks such as question answering, information retrieval, and recommendation systems.
The process of generating a knowledge graph typically involves identifying entities and their relationships from unstructured or semi-structured text. Different techniques have been developed to do this, including deep learning models, rule-based systems, and graph-based methods. The accuracy of the knowledge graph largely depends on the accuracy of entity linking and relation extraction, making NEL an essential component in this process.
Despite the progress that has been made in NEL, there are still significant challenges that need to be addressed in order to improve its performance and scalability for real-world applications.
One of the primary obstacles is the identification and disambiguation of named entities in context. This is due to the existence of multiple entities with identical names across different domains, making it challenging to accurately link the correct entity to the correct context.
Additionally, the limited availability of high-quality training data and cross-lingual resources presents an issue in NEL systems for languages other than English. Furthermore, the performance of NEL systems largely depends on the quality and coverage of the underlying knowledge bases, which are often prone to errors and do not adequately capture the diverse range of entities and contexts present in real-world applications.
Ambiguity in named entities is another challenge that needs to be addressed. Named entities can have multiple meanings depending on context, and without sufficient contextual information, it can be difficult to disambiguate them correctly.
Finally, multilingual support is an important feature of NEL systems that allows them to recognize and link named entities in multiple languages. This allows for more comprehensive and accurate analysis of text data, as well as better results for multilingual users. However, multilingual support also presents certain challenges, such as language-specific models and resources that need to be taken into account for optimal performance.
That's right. Now, let's move on to the evaluation of NEL systems. As mentioned earlier, evaluating these systems is a critical step in determining their effectiveness and efficiency in information retrieval and data analysis tasks.
There are two approaches to evaluate NEL systems: recognition-based and contextual-based evaluation. Recognition-based evaluation measures the system's ability to detect named entities by comparing its output to a gold standard dataset. Contextual-based evaluation, on the other hand, involves measuring the system's ability to link named entities to the correct entities in a knowledge graph.
Right. Additionally, various metrics can be used to measure the accuracy of named entity linking. NEL systems, such as precision, recall F1 score, and entity coverage. Precision is the ratio of correctly identified entities to the total number of identified entities, while recall is the ratio of correctly identified entities to the total number of entities in the gold standard dataset. F1 score is a composite measure of precision and recall, and entity coverage is defined as a proportion of entities for which the NEL system is able to provide a link.
Finally, we come to standard datasets for evaluation. These datasets provide a consistent and objective measure of performance across different systems and are typically annotated with named entities, their corresponding types, and links to external knowledge bases.
Right. So now that we have a good understanding of the fundamentals of named entity linking, NEL, and the evaluation metrics used to measure its performance, let's look at some of the potential applications of NEL in various industries.
One promising field where NEL can have a huge impact is healthcare. By analyzing patient records and linking them with medical codification systems, the accuracy of medical diagnosis can be improved. In addition, NEL can be used to identify new drug targets and understand the relationships between diseases and entities in medical literature.
Another area where NEL is useful is in social media analysis. By accurately linking entities mentioned in conversations, it can help companies understand customers' opinions and preferences. NEL can also be used to detect fraud and verify claims on social media platforms.
Finally, NEL has potential applications in natural language processing, NLP, as well. By leveraging knowledge bases such as Wikipedia, NEL can provide contextual information about entities within text, allowing machines to better understand the overall meaning of the text.
This brings us to our last point, research topics for improving the performance and accuracy of NEL systems. Researchers are continuously looking for ways to improve NEL tools by incorporating advanced natural language processing techniques, machine learning algorithms, and cross-lingual capabilities.
Additionally, there is ongoing research into improving NEL's ability to handle complex language, such as sarcasm and metaphors, as well as developing more sophisticated algorithms for entity disambiguation.
All these developments are necessary for unlocking the full potential of NEL systems and taking them to the next level.